Picture a battlefield where the enemy doesn't march, it rolls. A tiny tracked tank gliding over shell-holed ground, no crew inside, carrying a buried heartbeat of explosives. A soldier watches it approach. Not a man at the controls, but a spool of cable snaking back to a remote operator hundreds of meters away. One command, and the little machine becomes a one-way missile. That was the Goliath. The Wehrmacht's answer to a brutal question: how to deliver a massive charge into the teeth of an enemy position without sending men to die. It was primitive, ingenious, and in its own way the ancestor of every unmanned weapon we fear today. By 1942 the mechanized battlefield had become lethal for assault engineers. Minefields, anti-tank obstacles, and prepared defenses stopped tanks and infantry alike. Clearing those obstacles cost lives and time. An unmanned vehicle that could carry a big explosive load straight into a wire, a bunker, or a tank park would be a tactical game-changer. Remove the risk from the human operator and deliver the punch remotely. The Goliath was tiny but complex. Look at it as a compact tracked chassis carrying a heavy warhead in its belly and a cable spool on its rear. An operator held a control box. Left, right, forward, reverse, and the commands traveled along a multi-strand cable. When the driver reached the target, the operator sent the detonation signal and the vehicle became a single-use charged mine. There were two basic families. The early electric models, SdKfz 302, driven by twin electric motors and battery packs, quiet, simple to steer but expensive and short-ranged. The later petrol models, SdKfz 303 variants, which used small internal combustion engines to extend range and speed and to reduce production costs. The Goliath's explosive belly typically carried a fight-ending charge, not subtle sabotage but raw demolition, designed to tear open wire, blow tank tracks, or wreck a fortified aperture. Doctrine for the Goliath read like a short, brutal playbook. Deliver the vehicle to a prepared launch point under cover. Unspool the cable and steer the vehicle toward minefields, anti-tank obstacles, or a fixed target. Detonate the payload in contact with a tank column, an anti-tank ditch, a wire obstacle, or the base of a concrete strongpoint. Watch an obstacle disappear and send follow-on forces through the gap. The Goliath saw service across multiple theaters. It was used on the Eastern Front, in Italy, and in the defense of the French coast during and after 1944. Units were committed where obstacles and beaches had to be breached quickly, exactly the scenarios the designers had imagined. But operational reports were mixed. In some cases the Goliath did reach and destroy legitimate targets. More often it was disabled by artillery, infantry with simple tools, or the cable itself being severed. The device's small size also meant it could be flipped, dragged into ditches, or neutralized if spotted. The Goliath forces us to look at unmanned warfare before digital guidance and drones. Operators sat behind cover and guided a vehicle whose only purpose was destruction. The human interface, a joystick and cable, separated decision from consequence in a new way. That separation raises questions that matter even today. How does distance change moral risk? Does a machine that removes the operator from direct danger lower the bar for sending explosives into crowded, cluttered battlefields? The Goliath was a crude experiment in what would become a major ethical and tactical debate in modern war. Allied troops developed an effective cookbook of responses. The cheapest, most reliable tactic was detection and physical denial. Spot the vehicle and push it into a ditch, turn it over, or drag it into water. Cutting its connection to the operator rendered it inert and sometimes allowed the defenders to tow it back for inspection. Artillery and small arms fire frequently disabled the thin-skinned chassis. When engineers examined captured examples, they found fragility where designers had hoped for disposability. In some sectors, units laid hidden obstacles, shallow trenches or logs, specifically to trap small tracked devices. Others used grapnels or bayonets to snag the control line, yanking it out of play. Even anti-tank teams, trained to attack Panthers and Shermans, found the Goliath an annoying but manageable hazard. These countermeasures reduced its battlefield value faster than any production shortfall. Germany invested industrial effort into the project, churning out the machines in modest numbers. Estimates put production in the thousands, a serious commitment for a weapon with episodic successes.
Altogether, there's a bit over 7,500 of them are produced during the Second World War.
Building them required dedicated components: motors, gearboxes, detonators, and the guidance gear that tied operator to machine. As the war strained German resources, prioritizing expendable demolition vehicles became increasingly difficult. Production lines were forced to compete with tanks, aircraft, and conventional munitions. The result was a weapon that was present on many maps, but rarely decisive where it appeared. Even when it failed to hit its intended target, the Goliath could achieve limited psychological goals. For defenders, the sight of a tiny tracked charge crawling forward had a novelty that produced momentary confusion, a distraction that could be used to mask a real assault. The Germans counted on that moment of surprise. In practice, however, such effects were brief. The novelty faded after the first dozen encounters and troops quickly adapted. Tactically, the Goliath nudged doctrine in small ways. It forced engineers and infantry to account for small, remote threats, to sweep likely approaches and guard control points. It also gave planners one more tool, a disposable carrier for large charges that could be used when stealth and minimal human exposure were prioritized. The Goliath's real legacy sits in lineage more than in battlefield glory. When the guns fell silent and engineers returned to laboratories, the lessons of an unmanned, guided demolition vehicle endured. Mine-clearing rollers, explosive line charges delivered by vehicles, and eventually radio-guided platforms, inherited problem sets first exposed by the Goliath, guidance reliability, survivability of the carrier, and the vulnerability introduced by a physical control link. The ethical conversation that surrounds remote lethal systems today, about distance, responsibility and moral hazard, can also be read back to the Goliath era. It was an early, blunt test of what killing at a remove means for operators and commanders. Was it brilliant, or simply doomed by its era? Answering that requires separating concept from capability. The idea of a remotely delivered demolition charge was forward-looking. Remove the human from the most dangerous task and deliver explosives where needed. Conceptually, it anticipated many modern solutions. Practically, however, the Goliath was constrained by 1940s technology. The available propulsion systems, control methods, and materials engineering were inadequate for a robust weapon that could survive the chaos of modern battle. The physical tether guaranteed that defenders had a single, exploitable point of failure. Viewed in its historical frame, Goliath was neither total genius nor outright lunacy. It was a plausible attempt at solving a lethal problem with the tools at hand. Where it failed, it provided hard engineering lessons. About guidance, about testing in realistic terrain, about the necessity of survivability in unmanned systems. Those lessons helped shape later approaches, from post-war demolition robots to contemporary UGVs and combat drones. The Goliath stands as a striking early milestone, an honest, imperfect attempt to substitute machine for man in the most dangerous act of combat. It was a product of necessity, constrained by the physics and electronics of its time. It failed more often than it succeeded, but it taught invaluable lessons. Its descendants are now ubiquitous. Small robots that clear mines, remote vehicles that inspect roadside bombs, and airborne drones that orbit battlefields. In that lineage, the Goliath is the crude, wired ancestor. A technological embryo that hinted at a future where machines would carry much of the battlefield's danger.